So with that, let's welcome our panel and give them each an opportunity to introduce themselves and how they fit into our discussion today. I'm just going to start alphabetically, which means Christine, you get to go first.
Hi, I'm Christine Gemperle, and I'm an almond farmer in the Central Valley of California. And I've been cover cropping for almost 10 years now. I'm also on the board of Project Apis M. So I'm quite integrated into both the almond world and the bee world.
Okay, so next, well, I'll just go around the horn here. So now it looks like Marc-Andre Roberge.
Yep, sounds good. Thanks for having me today, Tim, and the folks at Silicon Valley Forum. My name is Mark. I'm the co-founder and CEO of Nectar. At Nectar, we are a precision beekeeping technology company. We work primarily with commercial beekeepers, migratory pollinators, and we offer them a tracking solution to compare survivorship and rentability to management practices and locations that they visit. And on the other end, we're looking at establishing links between survivorship and rentability to the different agricultural management practices, such as cover cropping at scale.
Okay, thanks, Mark. So Neal, can you go next? Oh, hold on, you're still on mute, Neal.
Sorry. Hey,
there we go, you're good.
Hi, everybody. I'm Neal Williams, professor of entomology and sustainable agriculture at University of California, Davis, in the heart of Central Valley production land. And our work has looked at a diversity of different questions related to both managed and wild bees, looking at how to increase the structural and biological diversity in agricultural systems to improve bee health and the sustainability of the services, pollination that they provide, and increasingly trying to work towards kind of more holistic inclusion of these beneficial organisms into the overall agricultural system.
Thanks, Neal. And John, you get to close us out here with the intros.
Thanks, Tim. Thanks, Dennis. I really enjoyed this opportunity. I grew up in a beekeeping family. My great-grandfather began the operation, and he was the first guy to move bees across the nation on a rail car, kicking off modern migratory beekeeping a little over a century ago. I bought the outfit from my dad in 1997, and I sold it to my son in 2019. He's generation number 5, and I get to teach generation number 6. I'm on this planet to take care of bees. That's what I do. Thanks.
Awesome, thank you. So the way from having discussions with, and you can see we've got quite the diverse panel here, and I was really excited how it all came together with the diversity of panelists and sort of the, and also how all of their disciplines weave together to tell this great story. And so what we did, and while I'm working here, I'm gonna share my screen, is we broke our discussion today into 3 buckets. And really to highlight some key challenges and opportunities for all of agriculture and how we can incorporate more regenerative and tech-savvy practices to help both drive conservation while also enabling farmers to maintain their bottom line. And so when I use farmers in this context, I'm really the broad aspect of farmers, right? Like John is a farmer, Christine's a farmer, right? Like anything from animal agriculture to row crops to orchard crops. I mean, farming is diverse, and we'll hear about some of that diversity today. So the first topic we'll address today is threats to commercial beekeeping. So in my opinion, logically, we'll start with John. So as a 4th generation commercial beekeeper, can you help set the stage with some of the major stressors to honeybee colonies? And I guess you could build on what Marla started and really bring it home from the commercial perspective. She laid out some of the things here, but I think you can really put a personal touch on it as a commercial beekeeper.
Well, thank you. We've been in this multi-decade fight with Varroa destructor, which impacts beekeeping globally with our Western honeybee, because our Western honeybee has no natural defenses against Varroa destructor, but we're turning a corner on that. So parasites, pasture, the lack of flowers, Marla nailed it. We just don't have enough flowers. That would fix so many things. Pesticides are still an issue. Beekeepers and growers work closely together because we want their crop to prosper and they need our bees to also prosper. So it's the 3 Ps: pasture, parasites, pathogens, problems. But we're working on them.
Okay, thank you, John. And it's really a continual process, right? In the beekeeping world, I mean, you're not winning at any point in your migratory process unless you're really worrying about each of those stressors throughout that migration that those bees are taking across the country, right?
Sure, and we think like farmers think, we think like tech people think, we think like Western growers think. Is what are we doing today to get ready for 180 days from today? And that's also moving to multi-year. What are we doing today to be prepared for 2023? It'll be here before we know it.
So we'll build on that, John, and some of the other topics. But yeah, I mean, really, that forward thinking aspect is really essential to everything we're going to learn throughout this discussion. So I'm going to switch gears a little bit. So I'm going to go to Christine. So as an almond farmer, you're really the first stop for most commercial beekeepers in the spring, right? When they're moving their pollination routes in the spring. So how do you view this relationship, the beekeeper-grower relationship, and in that context?
Well, I've always thought of the beekeeper almond grower relationship as symbiotic. We absolutely need each other. I mean, we obviously need the bees for the pollination, but the income from almond pollination is what keeps a lot of beekeeping operations going. As many people don't know, the prices of honey have not been the greatest. So with that in mind, as an almond grower, I always felt it's really important if I'm this is my field right here, actually late in the spring with a lot of clover growing. If I'm going to have a good crop, I need healthy bees. If I'm going to have healthy bees, then I need something to support those pollinations. And I like those pollinators. And I like to do that by providing something for those bees to forage on when they get to my property sometime in January to start those colonies going, get them up and running, producing brood. Because if they're producing brood, then they're going out and collecting more pollen. That's more pollination. So I started planting cover crops about 10 years ago with my personal benefit in mind, but also thinking like, okay, if my beekeeper really likes having his bees on my property because they come out stronger, then my beekeeper is always going to keep me as a client. And so when there's a shortage, I don't have to, worry so much. I want to be his first pick. So I guess it was a little bit selfish on my part, but at the same time, I did really feel, the need to provide for bees because I was also doing a little beekeeping of my own at the time. And I could see the differences in the health of the colonies. So it made sense. Going forward, we realized that doing all this cover cropping in the middle was actually helping out the soil health in the orchard. And so our soil it held on to moisture a lot longer. We didn't have to irrigate as much and for as long as we did. And then I also found that it cut back on some of my problematic weed issues that I was having. So there were all sorts of benefits that came along with trying to provide for pollinators. Right.
Well, thank you. I mean, I love looking at these pictures of habitat mixed in with agriculture. So I'm going to jump over to Neal. Neal, so can you tell us a little bit about your research that is kind of focused at the landscape scale? And I popped up this slide that kind of you'll use for each of your sessions here. But really focusing on the landscape level aspects of farming communities and some of the research you've done in that space.
Sure. So that would focus everybody who's looking here. Sorry. That would focus everybody who's looking here at the middle section of the slide, or at least that's what I'm thinking here. And what we're targeting here is trying to think again beyond the level, or I guess incorporate practices at the level of individual farms or individual beekeeping operations. So what John and Christine talked about, and how those play out across the larger landscape to benefit pollinator health and pollination. And one of the key questions we have, and this is something that's come out of collaboration with the Almond Board of California, with a bunch of different growers, with various agencies, is trying to better understand where we might place these amazing habitats and cover cropping and this kind of thing across the landscape to best benefit bees, both in terms of providing a continuity of food, of high quality forage for them, and also minimizing the exposure risk that they have to pesticides. And so one of the challenges we have is thinking from the individual operation to the whole landscape. And so this is where some of the work we can do is helpful. And so what we can do is work with existing large data sets across whole regions, counties, multiple counties, the entire Central Valley, and use that information to map. And what this slide is showing, here's a Central Valley picture, and then on this funny thing on the right-hand side with the orange highlights, what we've done is to use various techniques to identify areas that are essentially a cookie cutter cutout of that landscape that represent areas that are opportunities for the planting of off-crop forage habitat for bees, all these other areas. And so we can intersect lots of information to try and identify those. Where this also becomes useful is to understand who is managing and owning these different types of land. Is it public land? Is it private non-agricultural land? Is it farmed land? Is it fallowed land? And by understanding that ownership, we are interested to know whether how much of a benefit that someone might get from enhancing that habitat. Someone like Christine, how much does that affect her bottom line? And how much might that help the neighbors around her? And this kind of information takes us from the pure realm of the agricultural, what I call biophysical practices, the actual growing, to also the social side of it, so that we, as practitioners or growers, might know whether actions that they collaborate on with their beekeeper or as neighbors in the larger landscape might provide the kinds of synergistic, more than additive benefits that Marla Spivak was talking about. So does collaboration essentially lift all boats so that we can identify places where it can be most beneficial? And you can imagine that being true for forage. Certainly can imagine that being true for creating, for example, relatively safe zones for beekeepers with respect to pesticide exposure risk.
Right. And so how those risks and how those benefits are interacting across the landscape and really taking the holistic view, right? And so it really makes me think about I think Dennis mentioned it early on, and maybe Josette will talk about it later, but the California Pollinator Coalition, where we're bringing together these organizations that are looking at common practices to benefit pollinators throughout those growing regions in California. Well, thank you. So Mark, as the technology provider in the group and the what I'll call you're really the tech savvy guy compared to me for sure. But so how do you view these stressors on migratory beekeepers? And I love this photo you provided here. Then I wanted to put it in here because this really makes me think a busy day in the orchard in California is what it makes me think.
Yeah, pretty much. All right. So in terms of the different stressors, I don't have anything specific to add beyond what Dr. Spivak and John added from the beekeeper's perspective. It's parasite, pesticides, lack of forage, etc., that do affect commercial beekeepers and wild bees in general. That being said, something that we've identified where we saw we had an opportunity to help is the inability to measure long-term effect of the different locations and management practices from the beekeeper's perspective at a large scale. So when the commercial operation goes between 6 to 12 different locations throughout the season on their migratory path. Often, like, you're gonna mix up the hives and lose track of, where every individual colony was where. So the system that we have developed enables to correlate survivorship and rentability to past locations visited. So compare orchards, essentially, for example, in almonds, or the different management practices, such as types of feeding, types of breeding material that I have with me, different types of treatments for parasites and diseases. So that's what we've built. And the goal is to help, the beekeepers to identify the harmful locations or the good locations. And
So really looking at the health of that colony after it makes its migratory journey throughout the season, and then doing a hindsight analysis of those that won and those that lost out of those groups, and if there's a landscape level effect that you can tease out based on their sort of unique histories.
Yeah, exactly. And we're lucky to be able to tie this data with researchers to look at, on one end, the management practices of the beekeeper, but on the other end, also the different agricultural practices from the grower's perspective as well. Comparing at scale, effects of cover cropping or different types of mixes, for example.
Yeah, so I think what we're gonna do is you're gonna notice we're gonna move on through our topics here fairly quickly, because we took a big bite. But that really sets the stage for this next topic of, really, we teed this up as regenerative ag in both sort of the beekeeping and the ag space. So our second topic is sort of the thoughts on regenerative ag from our different panelists. So Christine, I'm gonna start with you this time. So by most standards, I would imagine you're considered a fairly progressive orchard farmer. Can you tell us a little bit about your view of regenerative ag and how it fits in with how you farm in California there?
Well, first of all, I'd like to say that regenerative ag, it's not the same everywhere. I mean, it's not just one set of practices, and what works in the Midwest doesn't necessarily work in an orchard system or even in specialty crops. So it's important to understand that it's sort of a group of changing practices. But one of the things that, I've really taken to is cover cropping, as I've mentioned before, because I've realized that with this, there's all sorts of benefits that have come into play with it, like the weed control, the beneficial insect population, obviously for the pollinators. Other things that our industry is doing is whole orchard recycling, where we're taking a whole orchard and grinding it up and putting it right back into the ground. And so, we're building our soil health and sequestering carbon at the same time. But again, just to reiterate, it's important to notice that what works for one system does not necessarily work for another system. So there has to be this sort of flexibility, and it's really about stewardship of the land.
Awesome. And I didn't include that photo because I didn't have a good handle on what was going on there, but really, I'm guessing that's maybe your son and husband standing on top of the mulched pile of trees.
That is my brother. Yes.
Okay.
So it's on a giant pile. It's basically the orchard ground up, getting ready to be spread.
Yeah. And so hearing that now, I mean, that is an amazing image that it really ties in. I mean, so one of the practices that I love and that we do is, the best thing I ever bought was a backyard chipper. And so anything that falls out of my yard or comes off my property gets chipped and run through this chipper and gets put back on the same property that I have. I'm not a huge fan of those yard waste containers that they give you, and you can send your waste to the municipal dump and kind of have it commingled, and then they produce mulch that people can buy. But and my theory is the same as what you're saying, is you take what came off the land, put it back in the land, and really build what you have at your house or on your farm.
And it's going to save us water in the long run, because you can hold on to 20% more water in those soils.
With the increased organic matter.
Right.
Yeah. Awesome. So Neal, I'm gonna jump to you. And so you've got a lot of research. And so really what I want to know is how does your research really tie into this idea of regenerative agriculture on our modern farms?
Yeah, great. And you could put that slide back up if you wanted.
Yeah, I'll pop it back up here.
Yeah, so all of our research, although we're a lab that in name focuses on pollination and native pollinators, all of our research, I think, has been geared and is increasingly geared at this greater integration that Christine is talking about. So, for example, in the mapping across landscapes projects that we do, we don't only map areas for bee habitat, but we're combining that with ways to understand how spatial location of coordinated action on growers for integrated pest management. So that's how they're managing key pests in their almond orchards, how those can also benefit, but how that IPM coordination meshes with pollination. So the 2 or 3 or more practices together, what we call stacked ecosystem services for agriculture, so that we get more than a benefit just for pollination. Because I think, again, for me, a really important element here is to recognize the economic bottom line for both growers and beekeepers. It may be that a practice that only targets bees is simply not palatable for the average grower when they think only about bee health. But if they recognize, as Christine does, the other benefits that same action is providing beyond bees, then adding them together, they see this much greater benefit. The same thing applies to our research, the first set of panels, which is where we've been working to design different plant mixes. And this echoes Christine's point that not all practices will fit everywhere. And so what we're doing is designing mixes that are region specific, that incorporate combinations of native vegetation and non-native vegetation. And because we're researchers, not practitioners, we're trying to understand sort of the details of how those plants operate, which ones are most preferred and provide greatest benefits for bees, but also which ones provide benefits for natural enemies, these predatory insects that help pest management, and trying to avoid species, for example, that support key pests of almonds. Those are the ones we'd want to not have, no matter what, in our mixes. And so, we do both field work on that, and we do a lot of relatively fancy computational modeling to aid growers and practitioners in how to decide which plant species to pick based on their cost and their function. The research spans a variety of different areas, but again, to reiterate, it really is trying to understand how benefiting bees fits more completely into the whole agricultural system. And that's this whole aspect of what is really the regenerative nature of the practices.
Yeah, and I think everyone hopefully is starting to see this all come together, right? And how it's gelling. So continuing down that. So John, I mean, how do you sort of in your system, I mean, just helping to benefit the bees in the commercial aspect of moving the bees and manage that stress on those beehives?
Well, we're big fans of cover cropping because an almond grower has a huge investment in the bees. Those forage projects anchor the bees in the orchard, so they aren't flying off the orchard looking for forage. They're staying grounded, anchored, if you will, in the orchard. And just this morning, the open enrollment on Seeds for Bees dropped, and that's just this morning. So the almond growers listening in this, here's an opportunity to embrace cover cropping, and I'm pretty excited about it because it does help manage the stress on those bees. No, it's very good because when a honeybee arrives in an orchard in mid-January and there is nothing blooming on the floor of the orchard or in the orchard or anywhere near the orchard, that's a desert. If we can get seeds in the ground in October and have them blossoming by mid-January to the 1st February, just a whole cascade of stacked events, just like Dr. Williams described, are possible.
Yep.
Great.
To really drive that health of the bees further down the pollination journey throughout the year. So Mark, I'm going to finish on this section with you. And so this is really the question about technologies from Nectar, and then how that partners with commercial beekeepers and farmers to better manage their operations, and really talk about these synergies and relationships that are happening.
Yeah, I think from our perspective, we hope that Nectar and the data that we're generating can help to build that bridge between growers, researchers, and the beekeepers. I think that's been our approach for since we've built that technology. So for example, what we're looking at is, can we establish insights on defining which regenerative practices are better suited for Sacramento area almonds versus Washington State apples, for example. Right now, there's big broad approaches to be able to provide different different types of cover cropping mixes for the different regions, and we're looking at capturing that data at scale and to facilitate the conversation between the different stakeholders.
Yeah, I think it's a great example of technology working with the system instead of trying to really change the system. So with that, I'm going to jump back to our outline here, and so now we're going to really transition into this role of technology, and that transition is, I guess, like I just said, right, as a part of the biological system versus trying to replace that system. So how is technology fitting in here? So Neal, I wanted to start with you here. So this is, again, translating research and discoveries into actionable items and growth opportunities on farms, right? Like, you're not in the business of actually doing that, but setting the next stage or the next investor up to be able to make that jump from discoveries you've made to something that can be used either on a commercial beekeeping or farming operation.
Yeah, absolutely. And I appreciate your comment and the candor of the point, which I would reiterate, which is, as an academic, there are a lot of academics who are very passionate about creating their own tools to be used. I think over the years, what I personally have found is we're not well suited in the business to designing tools that are used by growers or beekeepers. There are other groups that are much better at that and already have the reach and connection. What's a much better synergy between the research community and those stakeholders, those practitioners, is to provide that information and let others, whether it's Silicon Valley or others, design and help create those tools that are broadly applicable. And so I think that's a really exciting way forward. I guess my own feelings on what some of those tools would be. We talked about this as we're preparing for the panel. I am a really strong proponent of the point that you made. The technologies that I think are most interesting, and it's partly because I believe in trying to benefit the whole system and the long-term health of bees. Those are technologies which do not try to replace bees or the system, or they're not focused on mechanical solutions to what bees do, and that could be, pollinator or whatever it is, but rather they're systems that work to improve both the what I would say the decision-making process that is bombarding growers and beekeepers on a daily to weekly to annual basis, and technologies that make information very rapidly and accurately available to those different groups. And I think Marla Spivak said it really well. I was sort of amazed at how beautifully she set that up, talking about information availability and the kinds of technologies that are useful. And I don't think I could say it any better than she did. I think if we look at all of these different panels that I have here, in each case, there are examples of that kind of technology. So we create algorithms that help growers make decision tools, but I don't make wrappers for cell phone applications. And that's really expensive, and somebody else is really good at that. So we are always interested to partner with those who say, okay, we have databases, how do they turn into things that Christine could use for this spot or that spot to make those decisions? How do we take these pipelines of decision-making for mapping opportunities for bees and make them into usable applications that John can say, well, I could put my apiary here this year, or I could put it there, but it looks like this area is going to provide a lot bigger benefit based on how I could assess it. And that's, I think, where Marc's work with Nectar, right? He'll have the tracking of hives. Well, we have the landscape information. How do we marry those two, or who's going to marry those to make that information available? And then the final one is this pesticide exposure risk. So we test residues in pollen. We put hives out as sentinel gatherers of pollen to look at where pesticide exposure risk varies. We also develop landscape level sophisticated models of predicted pesticide exposure risk. We don't make those wrappers available to the public. So technologies that build on these research, but then make them usable to the community of practice is where I think is most valuable.
Awesome, thank you. I think so. We're gonna so the panel knows we're butting up against time, and so we got 3 more in this section, and then we'll do a speed round at the end for everybody, just to kind of closing thoughts. So Mark, I'm gonna go to you. So technology developers, how are you guys thinking about creating value products in this complex environment of agriculture that we're talking about?
Yeah, I think either it's from Nectar's perspective or from any technologist's perspective approaching the space, the mindset should be about embracing the fact that the tech itself is not going to be the sole solution to a complex problem evolving in a complex biosystems. Either you're seeing it from the bee's perspective as being a super organism that will react differently to different environments, or from different agricultural landscapes that the bees visit, right? So I think the mindset, should be to collaborate as much as possible with the different stakeholders. So in our process to build our tracking system, for example, like we've been working with John's son, Jason, and Miller Honey Farm to co-develop the project. We've been working with different research groups such as Washington State University to develop the insights as well. Neal, I think we should talk as well. It seems like there's a couple of potential synergies there. But essentially, it's keeping that feedback loop active with the different stakeholders, right? So involving the growers, involving Project DPSM. We also have a project with them to look at the effect of different types of feeding, varroa treatments, cover cropping effects, etc. And embracing, that the fact that the tech is not going to be the sole solution. It needs to be part of the system, and it really takes a village to tackle such a huge problem.
I think that's a great way to think about this. So Christine, we're going to take it back to the farm. And I like this image, and I think it speaks to a little bit of what you were talking about earlier with how you have this, how you've more embraced technology and how it's helping you with your journey along one of the aspects here of regenerative ag, and how it's benefited your farming operations.
Well, technology, in my opinion, it really needs to fit into the biological system. In order to do that well, you need to study the system in order to incorporate it. It's all about precision ag at this point, and what actually saves me time. So it needs to be concise. It needs to be uncomplicated to help me make the best decision. I mean, data for the sake of data is just a time suck. So we kind of, we don't want to get caught up in that. And then the final thing is actually it's financial. So, something that saves me time and resource should save me money, but the technology has to be affordable. So if it's a $10,000 investment on tech that only saves me $2,000, I'm not going to do it no matter how cool it is, because I can't afford it. That's just a poor investment. So don't skimp on the economic analysis when it comes to the technology for growers. I mean, anything that has to do with water or problematic insect monitoring could be incredibly beneficial, because it can save me water, it can save me time on the tractor, and pesticide use.
I love it. I think you really nailed the point there. And John, I love this image. I'm glad to put it up. I'm gonna pitch it to you for our last part of the technology, sort of on the farm and in the operation. And so, can you tell us a little bit how you've incorporated technology in your overwintering operations, and how it's really impacted how you manage the bees?
Sure. We started looking at indoor wintering, which is not a new concept, but doing it with applying all the available tools to manage the interior environment, the health and well-being of the bees. but the fundamental focus of taking a bee indoors was trying to, I'll steal Marla's line, our human thoughts and needs should subordinate to the superorganism's needs. And a honeybee winters in northern Germany, usually inside a cavity that's dark and quiet and cold, or cool, very cool. And we just tried to duplicate that with this building. And other guys are successfully wintering bees. The takeaway for us was we were able to reduce our winter losses from like 35% of the outfit to 7% of the outfit, just by applying what the bee has been trying to communicate to us for 10,000 years. This is where I winter best, in this deeply restful place. What we applied was the available technology to make sure it really works, and it does.
So John, how many beehives are we looking at in these storage barns you have, the Winter Palace?
Yeah, the Winter Palace, because we blew our budget to smithereens. This building's designed to hold 18,000 hives, and it does so comfortably and efficiently. Other buildings hold more, other buildings hold less. The Canadians, who did a lot of the pioneering work here, usually run 1,000 to 1,500 colonies in their indoor buildings, and we're Americans. We scaled everything to gargantuan.
You brought Texas to winter storage.
Yeah.
Okay, so perfect. Thank you, everyone. And I've had a lot of fun interacting with you. I've learned a lot from everybody on this panel. We got a couple minutes left. I just want to do a speed round of like final thoughts, long-term perspective, vision for regenerative ag, and let's all try to do it in 30 seconds. So John, you're not on mute and you were just going, so I'm going to start with you.
There's a lot of tech solutions out there, but I loved what Christine said. Don't waste my time, don't waste my money. You know, this ag is not beanbag. It's not easy, and you have to be applied and all in to succeed. And we see successful operations. We touch lots of crops and we see what's working. Unfortunately, we sometimes see what isn't working.
Perfect. Marc-Andre, can you go next?
I think I'll finish with a question to the panel. I mean, not to answer now, but to the panel and the public. It's there's a percentage of fairly low percentage of almond orchard and other crops that are converted to cover crop, and have some conservation areas. So really, the question to answer is, how do we make it 100%, right, of regenerative or at least sustainable growing practices across the nation, across North America, 12 months a year? That's what I would finish for.
Love it. Neal?
Wow, my mind was kind of blown by that last question. So I'm a little bit, or that last point, so I'm a little thrown. I guess just rather than saying the same thing, I would just reiterate the need to think about the technology in the way the world is going to be. So I think the opportunities exist at the intersection of the agricultural ecosystem that includes the social dynamic. The grower, the beekeeper is part of that managed system. So looking at technologies that way, and recognizing, as Christine alluded to, if you're in California, our world is changing dramatically. It's not only about bees as bees, it's about bees as they relate to water. What is the pattern of available land going to be for the bees? Where are they going to go? Thinking about these kinds of things much more on a forward-looking scale will be where the technologies are going.
Yeah, the societal concept there of everyone and the environment working together. So Christine, as the almond farmer, closing us out.
All right, I have 2 points to make. First of all, you have to look at sustainability as sustainability for the farmer just as much for the land, because the land is not going to farm itself. The other thing is you need to look at the investment in the future of ag and the honeybees in particular as an investment in humanity. We all need to eat, and our food supply is dependent on the successes of these biological systems that are threatened by human activity and climate change. When I think of global tech giants, I can't help but think that all of humanity is your target audience, right? And I would think that the ROI on an investment in humanity would be a pretty good one then. So that's it in a nutshell.
I love it. So Dennis, back to you, and hopefully we didn't set the stage too high, set the bar too high.
I do not want to follow Christine, except I now have no choice. But at least, Christine, you made the addressable market all of humanity, so that ought to get a lot of people's attention. So Mark, go get them and try and sell them. Just keep the economics right. So anyway, well done, everyone.